Let's talk about 2.5. It's my favorite word problems in the whole book. Have I already said that before? They're all my favorite, but this is really my favorite. In word problems, it's hard to give you a rule. You know, if you do this, this, and this, you'll always get the right answer. It seems like every problem's just a little bit different. I tried to show you examples of mixture problems, investment problems, rate, time, distance problems, give you an idea of what the chart looked like so that you could use it to organize the information. But, buddy, I have 4 steps on 2.5 that other than, you know, punching something wrong on the calculator, if you'll follow these 4 steps, you will get all of these problems right, and you will feel smarter than you've ever felt in your life. That's a promise. All right. Section 2.5 is variation. And variation just expresses the relationship between 2 quantities. Either as one thing gets bigger, the other gets bigger. That's direct variation. Or as one thing gets bigger, the other gets smaller. That's inverse variation. For example, your weekly pay, if you're not a salaried worker, you're an hourly worker, then your weekly pay depends on the number of hours you work each week. The more you work, the more you get paid. That's an example of direct variation. As hours go up, pay goes up. The amount of light you see from a candle depends on your distance from the candle. The greater the distance, the less light you see. That's an example of inverse variation. Whenever you see the words y varies directly as x, or that also means it could be y is directly proportional to x, or just y is proportional to x. All 3 of those things mean the same thing. They all mean that y is some constant times x. Now, we'll talk about what that constant may be in a minute, but when you see the words varies directly, or directly proportional, or just proportional, the first thing you need to think is y is some constant times x. In the case of your paycheck, y would be your pay. It would be your weekly pay. And what would x be? Yeah, the number of hours worked. And if I said your pay is some constant times the number of hours you work, then what would that constant represent? That's your hourly wage. Constant would be your hourly wage. Yes. That is hard to read, isn't it? There you go. So in that example, y would be your weekly pay, and you calculate your weekly pay by multiplying your number of hours you worked times your hourly wage. In that case, k would be your hourly wage. Now, if you see the words y varies inversely as x, or y is inversely proportional to x, then you need to think not y is a constant times x, but y is a constant divided by x. That way, as x gets bigger, y would get smaller. And then one other type of variation, when y depends on more than one quantity, you may see y varies jointly as x and z. That would mean y equals k times x times z. So in a situation where you have one quantity depending on 2 or more quantities, you still just have one constant times those other quantities. All right, here are the 4 magic steps. And if you have your own way of doing variation problems and you get the right answer 100% of the time, you don't have to use my steps. But if you're not getting the right answer darn close to 100% of the time, give these a try. Step 1 is always write the general equation among the variables using a constant k. That just means either write y equals k times x or y equals k divided by x, depending on whether the problem says varies directly or varies inversely. So the first thing is just decide which type of variation you're dealing with and either write y equals k times x or y equals k divided by x. The second step is substitute the given values of the variable to find the value of k. Maybe I'll give you some particular x value and some particular y value. You could substitute those in and solve for k. In this case, you would be solving for your hourly wage. The third step, once you know the value of k, substitute it back into your original equation to get a specific formula. And then number 4, solve for the required unknown. Those 4 steps only make sense when you see them in an example. So we're going to do a bunch of examples. This one I made up because everybody can relate to your paycheck. If your weekly pay P varies directly as the number of hours you work per week, then, and H is the number of hours you work per week, then what would your equation be if you have pay varies directly as hours? Would it be P equals K times H or P equals K divided by H? Times, because it varies directly. This problem is so common sense that you don't need to know anything about variation to figure this one out, but we're starting with a very simple problem to show you the steps, and then we're going to get to more complicated sounding problems and show you that the steps work no matter how ugly the problem looks. All right, so the formula we need is your pay is some constant times the number of hours you work per week. That's this step. Step 2, substitute the given values of the variable so that you can find that constant. Well, if you work 30 hours one week and make $240, what's your hourly wage? Yeah, and this one's simple enough. You can probably do that in your head. And another problem, you might need to put 240 in the place of pay and 30 in the place of hours per week and solve for K. Just divide both sides by 30 and you get that $8 is your hourly wage. Step 3, substitute that value of K, that 8, back into your original equation so that you have a general formula for calculating your pay. Your pay is going to be 8 times however many hours you work. Now that you have a general formula, as long as your rate of pay doesn't change, you can use it to answer a lot of questions. What will I get paid if I work 10 hours? What will I get paid if I work 40 hours? How much do I have to work to get paid $300? All of those questions can be answered once you have a general formula. And you can use that formula to predict something else. If you worked 40 hours a week, your pay should be same old 8. Put 40 in the place of H. Your pay should be $320. Again, you may be thinking, I don't need those steps. I could have figured that out. Absolutely. I'm sad if you couldn't figure that one out without any steps. I could have given that to you the first day of class and you could have figured it out. But learn the steps, trust that they work, and apply them to things that may be more difficult, more scary than any word problem you've seen before. Number 22 is another pretty straightforward, easy one. The monthly payment on a mortgage varies directly with the amount borrowed, B. It helps me in these problems to boil that first sentence down to as few words as possible. Basically, you just need the subject, the verb, and the object of the verb. Wouldn't Miss Vaughn be proud of you for knowing those words? The subject here is payment, and we're going to let P stand for payment. And then we need to know whether we're talking about direct variation or inverse variation. And then what does payment depend on? Well, payment depends on amount borrowed, and we're letting B stand for the amount borrowed. So what is my equation if payment varies directly with amount borrowed? Yeah, P equals KB. The varies directly is what tells me constant times amount borrowed rather than constant divided by amount borrowed. You know, the more you borrow, the higher your monthly payment's going to be. All right, going back to the problem, if the monthly payment on a 15-year mortgage is $8.99 for every $1,000 borrowed, you can stop right there and tell me which variable stands for what that $8.99 is. That's the payment when the amount borrowed is $1,000. So when B is $1,000, P is $8.99. That's all the information that you need to find that constant. Just put $8.99 in place of P and 1,000 in the place of B. Divide both sides by 1,000. And you get K equals 0.00899. Don't know why I wrote that out to the side when I had another arrow. Doesn't matter. So now we have found that constant. That constant's going to remain the same no matter how much you borrow. This is, what would that constant actually represent in this case? Ooh, somebody's saying it. That's your interest rate. So your equation would be payment. Payment equals this value of K times however much you borrow. The payment is 0.00899 times B. Now that we have that constant, we're going to be asked to use that general equation to predict something else. The something else we're predicting is in this last sentence. Find the monthly payment, that means find P, when the amount borrowed, that means when B, is $175,000. Find P when B is $175,000. According to the formula on the previous step, P is just 0.00899 times 175,000. Would somebody punch that for me? Somebody with a calculator handy? What's that monthly payment going to be? That sounds pretty reasonable. You said 0.25? Okay. That sounds pretty reasonable for a $175,000 15-year mortgage. Your payment would be about $1,573. Once again, applying the 4 steps to something pretty straightforward. You probably could have figured it out without knowing the magic 4 steps. But these on the back get a little more interesting. We're working our way up to number 40. If we get number 40 right, I don't know, we deserve some kind of celebration. That's not enough. That's not enough. I want donuts. I had donuts for breakfast, huh? I don't have any stashed away. I went by, got my 2 blueberry donuts this morning and was very happy. All right. The rate of vibration of a string under constant tension varies inversely with the length of the string. If a string is 48 inches long and vibrates 256 times per second, what is the length of a string that vibrates 576 times per second? My guess is this may be one that you could not, just fiddle with on paper and come up with. If you can, yay. The rest of us are enrolled in the 4-step program. Do I have any guitar players or any stringed instrument players? Isn't it true, Misty, that the tighter the string, the higher the pitch? Because the pitch is determined by the number of vibrations per second, and the tighter the string, the faster the string vibrates, and that causes your pitch to go up. So that's what's going on here. And the first thing we need to do is come up with an equation based on the most important words in this sentence. The most important words in this sentence are rate varies inversely as length. And that's what I've typed for you. Rate varies inversely with length translates into what equation? That's fine. That's fine. I'd rather use variables that I can remember what they stand for. So I would use R for rate or V for vibration, probably, instead of Y. I would put Y equals, and then did you say K times or K divided by? Divided by the length. If you're going to use L's, make sure they don't look like ones. All right, the rate of vibration is some constant divided by the length. If a string is 48 inches long, what's that 48? That's a length. When length equals 48, the vibrations per second is 256. That's all you need to find the K. I must have decided when I typed this to use V for vibration instead of R for rate. I need to keep my variables the same there. Is that what you were confused about, Christina? Yeah. That was my fault. I didn't look down and see that I'd already. Too many letters? Yeah, that would be. V for vibration, L for length, K is the unknown constant at this point. Put 256 in place of V and 48 in place of L. And how would you solve for that constant? You'd have to multiply both sides by 48 to clear out the fractions. K would be 256 times 48. And that's kind of a big number. Mr. Toby, you're my calculator guy. Do you have it? All right, 12,288. Now, it's harder to say in this problem what that K actually stands for. It was easy in my first example to say K is your hourly rate, or the previous example, K was your interest rate. Here, it's hard to say what K is. But I can put that 12,288 back in the place of K and have a general equation for finding the rate of vibration for any length string. V equals, now I know what the constant is, 12,288 divided by any length you give me. Notice that you're through with the 48 and the 256. That was vibrations for some particular length of string so that you could find that constant. Once you have found that constant, you don't need the 48 and the 256 anymore. We're asked to find what's the length of string that vibrates 576 times per second. Well, V equals, find L when V equals 576. Just put 576 in the place of that V and solve for L. How do you solve that equation? Only in this particular example. We're given one specific example, and after that, we have a formula for finding the vibration rate for any length. So how do I solve that for L? You have to clear out fractions, just like you did here. No matter what you're solving for, the first thing you have to do is clear out fractions. So you multiply both sides by L, and you have 576L equals 1,288. And then what would you have to do to have the L by itself? Divide by the 576. The length is the 12,288 divided by the 576. All right, 21, you could either round it. If the directions say round, you could write that 0.333 as 1/3. There would be more than one correct way to write that answer. Is that times per second or dollars, or what is that 21 and 1/3? That's inches, the length in inches. That's how long a string would need to be if you wanted it to vibrate 576 times per second. And that's probably dependent on what your string is made of. A copper string is not going to have the same constant as a steel string would have. But for any given string, if you had one length and one vibration rate, you could find that constant and then use that constant to predict anything else you wanted to. All right. Any questions? We're going to finish early, and I don't like that. I wish we were in a computer lab where you could all start your homework and I could help you. Yes, ma'am. It doesn't matter that you can come up with words for what K stands for. It does matter that you have the right number for K. But what I was saying is I wish we were in the computer lab so we could start the homework. All three of them. I can, but then I would just be. Can any of us pull it up? Yeah. Doesn't it come up there, right? Yes, but when you went home and tried to do your homework, it would give you different numbers. So you would still end up redoing the homework. Like I always take advantage of it. Usually when I get out of here, I don't have time to go do it. Yeah. Yeah. The reason this is going so quickly is really the amount that I typed for you. You're not having to write down a whole lot, but I wanted to save you that typing or writing time for you to actually be able to digest and think instead of just scrambling to write down. All right, number 34. The intensity of light measured in foot candles varies inversely with the square of the distance from the bulb. A student who had some theater experience or some knowledge of theater history once told me the reason that the intensity of light is measured in foot candles goes back to Shakespearean days when the stage was actually lit by candles at the foot of the stage. And the different scenes would determine how many candles need to be lit. You know, is it a day scene, a night scene, or whatever. But that's why intensity of light is measured in foot candles. The intensity of light varies inversely with the square of the distance. Now, It's important that you realize it's not just the distance, but it's the distance squared. If you use I for intensity and D for distance, translate that into an equation for me. Almost D squared. That's it. That's it. You just write the equation as you work your way through that sentence. I equals K over D squared. Don't mess up and put the square root of D or just D. It's D squared. Step 2, you give me some particular intensity for some particular distance, and I can find that value of K. So here's my specific. Suppose that the intensity of a 100-watt light bulb at a distance of 2 meters is 0.075 foot candles. Now I know that 2 is my D, but is the I the 100-watt bulb or the 0.075 foot candles? It tells you up here the intensity is measured in foot candles. That 100-watt bulb, the 100 it's just telling you what kind of bulb you have. All right, so when the distance is 2, the intensity is 0.0075. Ooh, too many zeros. I put the decimal in the wrong place. Thank you. That's all I need to solve for K. Put 0.075 in place of I and 2 in place of D. And then what? Well, divide, multiply. Multiply both sides by 4. And you get K equals 4 times 0.07. Oh, that was times. 4 times 0.075. That's just about as sloppy as anything I've ever written. What is 4 times 0.075? 0.3? That's just the constant for this 100-watt bulb. If I had a different bulb, it would produce a different intensity of light, and that constant would be different. But now that I know the constant, what's the next step? Write the equation with 0.3 in the place of K. So I equals 0.3 divided by D squared. And I no longer have 2 and 0.075 in this equation. This equation is for any intensity at any distance. No, step 3 is write the equation. We're not solving for anything, just write the equation. Step 4, use the equation to predict whatever you're asked to predict. That's always the last sentence. Determine the intensity of the bulb. That means find which variable. Find I if D equals 5. I would be 0.3 divided by 5 squared, or 0.3 divided by 25. What is that? Anybody second that? All opposed? Any opposed? All right. What's the units on that? What is I? It's intensity, and it's measured in foot candles. That's 0.012 foot candles. All right. This is the one that I want you to be really, really impressed with yourself. You've got one like it in the homework. I want you to read that problem, or I'll read it, and imagine how you would have felt if I had just started class with this problem. The volume of an ideal gas varies directly with the temperature T and inversely with the pressure P. Write an equation relating V, T, and P using K as the constant of proportionality. If a cylinder contains oxygen at a temperature of 300 Kelvin and a pressure of 15 atmospheres and a volume of 100 liters, what's the constant of proportionality K? And if a piston is lowered into the cylinder, decreasing the volume occupied by the gas to 80 liters and raising the temperature to 310 K, what is the gas pressure? It'll be so cool if we can figure this out. Let's think about that first sentence. The volume of a gas varies directly with temperature and inversely with pressure. However, how many of you have ever had anything to do with canning garden vegetables? You've either done it or you've watched somebody do it. You know, you have your canner, and when the water starts boiling, there's a cloud of steam above it, right? That cloud of steam is the volume of gas. What happens to that cloud of steam as you increase the temperature, as the water gets hotter? That cloud of steam, the volume gets bigger as the temperature gets bigger. You with me? All right. If we apply pressure to that, think of the lid of the pressure cooker, then what happens to the cloud of steam? It gets smaller. So volume varies directly with temperature. As temperature goes up, volume goes up. But inversely with pressure, as pressure is applied, the volume goes down. All right, I understand. Let's see. V varies directly as T and inversely with P. This is joint variation. Volume depends on more than one thing. I need an equation that starts V equals. How can you get directly with temperature and inversely with pressure in the same equation? K times T, I agree with that part, because it says inversely. K times T divided by P, because now this equation says two things. The K times P part is the direct variation. The K divided by P part is the inverse part, inverse variation. Correct. Always. 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 There are no exceptions. I like things that are always. No, I like things that are always. This is. All right. You give me some specific volume for some specific temperature and some specific pressure, I can find that constant. Hey, Miss Ashley or Ashton, do you need to ask something? Maybe somebody else has the same question. Is there something bugging you? Got it? Okay. Okay. So what particulars are we given here? If a cylinder contains oxygen at a temperature of 300 Kelvin, what is that 300? That's the temperature. T equals 300. And a pressure of 15 atmospheres. What's the 15? pressure is 15 in a volume of 100 liters. What's the 100? V equals 100. Is that everything we need to find the constant of proportionality? Yeah, that's the first question. What's the constant of proportionality? Find K. All right. Yes, ma'am. Okay. You're reading that sentence with a little bit incorrect in intonation. It's not the temperature. It's not that the temperature varies inversely with pressure. It's the volume varies inversely with pressure. The volume varies directly with T. That means some part of the problem has to say V equals K times T. And the volume varies inversely with pressure. That means some part of the problem has to say V equals K divided by P. So the volume depends on both the temperature and the pressure. Technically, though, this is the same thing because that K is over 1, and if you multiplied, you'd get back exactly this. Okay, let's find that constant. When V is 100, T is 300, and P is 15. You could multiply both sides by 15. I see something that's easier on this particular problem. You can simplify the 300 over 15 as just 20. That's just the faster way. 100 equals 20K. So what does K have to equal? Yep. What is step 3? Exactly. If that was K plus 300, you couldn't touch it. Glad you noticed that. What's step 3? Put that constant back in the place of K in your original formula. Don't use a specific temperature, a specific pressure, and a specific volume anymore. Just put that constant in place of K.
So do we get to find by dividing 20?
Mm-hmm.
Okay.
And then step 4, give me some other 2 values for either volume, temperature, or pressure, and I can solve for the missing one. So go back to this last sentence. If a piston is lowered into the cylinder, think about if the lid is lowered onto the pot. The volume is decreased to 80 liters and the temperature is raised to 310 Kelvin. What is the gas pressure? We're looking for P. What is V? 80 when, what is the 310? Okay, so when V equals 80 and T equals 310, we have 80 equals 5 times 310 divided by P. How do you solve that for P? First, you'd have to clear out the fractions, multiply both sides by P. And you could go ahead and multiply the 5 times 310 is 1550. And then divide both sides by 80. approximately what is that pressure now? Compare that to the original scenario. The temperature has gone up 10. The volume has gone down 20 cubic liters. And the pressure went up about 4 atmospheres. Any questions? I think this time next semester, I'm going to have a cart full of iPads that I can hand out and everybody can work on their homework in class, and that would be fabulous.
Yes.
But I don't have that yet. Next semester, I'll have that. Y'all just fail this semester and take it again next semester so you can play with the iPads. Yeah, we'll have it next time. All right, see ya.